Hello students, I hope you're doing well today. I wanted to spend some time just talking about the source that we'll be using for our course as well as the instrument to read that source. So the first thing I want to talk to you about is my function generator or a signal generator called a Sig-Gen or function generator. In this device, so you have an on switch here and it gives a display. And my adjustment for the display is right here. This is my frequency, so I can reach up here and adjust my frequency and change it. I want to always have this coupling to the internal for my class. If you look here, there's an indicator for kilohertz and just regular hertz. So if I click this down a couple, you see that this is reading 10 hertz. And then if I click it up to times 100, and I increase this to over 1,000 right there, it's going to go to kilohertz. We'll go to the red light. And then this one on the range is that this knob goes, this knob, if I have it on 1K, I can increase it to around 4,000 or 4K hertz. And I think it goes down to, it divides by, that's down to 45 hertz. So that's your range on this. It's usually about four times the setting and about 40 times below there. So it means that 40, I can go up to 40 on 10K. So if I have to go to 50 kilohertz, I'm going to have to go to 100, roll that back to 50. And then there's 50 kilohertz. So that sort of gives you an idea how that works. I always want to have my function on this sinusoidal wave here. There's some other things here you use for other classes, but for intro to AC electronics, we're going to be using this sine wave. Now when I'm looking at this thing, when I come up here and I have this set up, I've got this knob to wherever my range needs to be. This one's sinusoidal. The width and rate, I just leave at 12 o'clock. The offset, I don't mess with. The amplitude, so this knob here tells me this increases my voltage. AMPL stands for amplitude, and that tells me how high that signal is going to be. So that's sort of the controls we'll be using is frequency. This is our display for frequency. This is amplitude. And we will we'll have a one-time probe connected here with this BNC connector. Just slides into the main. And we are going to use this device to the left of it. It's going to be my oscope. And the on button's right there. And when a student has issues with getting signals on the oscope, I usually come over their shoulder and look and see what's happening. So I'll tell you what I'm looking for when I'm doing the signal. We're going to use channel 1. There's 3 inputs here. There's a channel 1, channel 2, and this is an external trigger. So we're going to use channel 1 most of the time. And when I come in here and I look at this scope, I'm looking for several different things. When I first come up is that the intensity knob. I try to make this as where I can see it. I don't want to make it over bright because it bleeds over if I get too bright. Then I'll adjust the focus to make sure it's in good focus. I make sure all my levers are up. In most cases, we want all these levers up. So there's 5 levers, these 2, and then these 3 in the middle. So those go up. The hold off is pushed in, and I rotate that to the left to the minimum. And you see my position knob. I'm moving my position knob here, and it moves my signal left to right there. And then I make sure all my buttons are pushed in. This one's pulled out. I'm going to push that one in. And then I make sure these things click off. I want to make sure these are rotated to the left. And then there's a variable sweep here, and this variable sweep needs to go all the way to the left. This will change the width of your signal, so you want to make sure that that's to the left to make sure it's properly calibrated. Then what I will do here is I'm going to take my function generator and I'm going to connect these 2 reds to red. And then I will connect my grounds together. So that's how we're connected. So basically what I've done is I've taken my signal generator and I've connected it to my oscope. I'm going to dial in about 10K, 10 kilohertz. We'll dial that in. I'm simply looking at my display and dialing it in. And then I've got my amplitude is just set halfway up, so whatever that happens to be. So this device can only read two things. It can read voltage going up and down, vertical for voltage, and it reads time going across. So that's all this device does. This is just a diagnostic tool that helps you view your sinusoidal wave or your signal. So let's take a look and see what we have here. My goal is to make this device as wide as I can and still keep one wave on there. As you see, my sinusoidal wave here starts off just a little bit. Well, I can adjust my trig here, my trig level, my trigger level, if you will. And I want to make sure that this signal is right in the middle. You see this hash mark right here in the middle. I want to make sure that that's my ground knob. So I'm going to switch this to ground, that first level to G and D to ground. And I'm going to move it over just a little bit. I'm going to push it back up. And I can adjust this from side to side with my position. And if my wave is starting up high, I can adjust the trigger level to where it starts on that line, what I call the zero line, and I move this over to the left. So it does appear that this signal can be caught into one window here, that complete signal. So we're going to move in and see if I can take a look here. There we go. And I want to measure across. I'm going to measure from left to right. And it looks like this is, we're going to call this 10 centimeters wide. This gradient on this device here is 10 centimeters wide. Each one of these squares is a centimeter. And going up and down, there are 8 squares or 8 centimeters. So in order to tell what my signal is I read across and I say that's 10 centimeters. My time per division knob is set for 10 microseconds. So I'm reading 100 microseconds. One cycle is equal to 100 microseconds, so it takes 100 microseconds to equal one of these. So my frequency is set at 10 kilohertz, so I'm going to take 100 microseconds, and I'm going to inverse that. So 1 divided by 100 microseconds. And if I do the calculation properly, you can see here is that I've taken this 1 divided by 100 microseconds and I get 10 to the third or 10,000 hertz. And if I look over here to the left, I see I'm have that thing set for close to 10K there. So let's come back to here. And what I want to do here is I want to measure what the value of that signal. So I read from the very top of the sine wave to the very bottom. So it looks like it's 2 squares here and 2 squares here. So that's 4 centimeters. And my time per division knob is set on 5. Oh, I'm sorry. Take a look here. Set for 2. So each one of those centimeters is equal to 2. So I am reading 2, 4, 6, 8. I am reading 8 volts peak to peak. One of the things I like to do is change my time per division knob. And I would like to squeeze my signal together, so I can simply look here and say, yep, that looks like it's 4 squares. And so 4 times 2 volts per division equals 8 volts peak to peak. So this is just a quick overview of how to use your scope, how to read the signal on there. And simply what we can read with the scope is volts and time. And we take that time signal, reciprocate it, and that tells me the hertz. And the hertz is what my function generator is set to. So hopefully this is a good overview. This will help you out. And if you have any questions, I'll be sure to answer those when you're in lab. Take care. Stay safe.